Hello everybody and welcome to the IGL Coatings Online Training Academy. This is by far going to be my favorite tutorial and probably one of the biggest reasons I flew to Malaysia is to talk about the laboratory side of things, to talk about the machinery, the testing, to talk to the scientists. And Pyong and Dr. Rafiq, can you tell us a little bit about why things are tested, why we need standardized testing? I know that ASTM is one international standard. There are other international standards. So maybe we don't need to talk about just ASTM, but let's talk about what a standard is and why standards are needed in the world.
Can actually explain a bit about the standards first.
Yeah.
And after I'll pass it to Dr. Rafiq to actually explain about his lab.
Yeah.
So,
okay.
So for the standards, right, actually there's just not STM. There's quite a lot of standards that we have globally. There's the ISO, there's the STM, then there's the Japanese GIS as well. So and there's a few other countries that actually have that, like this global standard system. So what's so important about it actually? Like why do you actually need it? It's really a way for a testing method, right, to be standardized, so that maybe you in Australia, us in Malaysia, running a test, right, that we minimize as many variables as possible, because in that document it lay out every single way how a test should be done, so that its result can be as repeatable as possible in a way. Because as I said, you don't want to introduce unnecessary variables. So that's why it is important. Otherwise, you run your way, I run my way, and then we try to it's no longer an apple to apple kind of like result of comparison. So that's why it's actually important in that aspect. It's meant to be done in a controlled environment, let's put it that way. So if you do it in an uncontrolled environment, right, then it's no longer standard actually. It's just random, and like that's not a proper way anymore.
In every industry that looks at testing or standardized testing, the purpose of that is to actually compare apples to apples.
If I may add,
of course,
underestimated part of standards is usually they put you to speak the same language. Because for example, let's say for curing, a lot of people have different understanding of like dry to touch, dry through. For them, or for person A, maybe it's something like this, person B is something like this. So what standard does is clearly in the beginning, it states what does it mean by this certain statement, so that when you read the result and your expectation all is equal. Because if not, there is no data is useless if it's like chicken talking to duck. Yeah. You're expecting something, this person is expecting something, and then it's not something that is solvable.
What Dr. Rafiq said is very true, the language. Because otherwise, right, especially in troubleshooting or even in comparison, right, I have my own perspective of dry to touch. He has his own perspective of dry to touch. You have your own perspective of dry to touch. And then the three of us start talking and comparing, you'll be like, okay, let's go with World War III.
that makes sense. But also I think, correct me if I'm wrong here, so if there is an ASTM for dry to touch or curing, well, I don't know if there is or there isn't, but that also means that another brand or another company can also run that ASTM, and their dry to touch is by the same definition.
Correct.
As our dry to touch.
Correct.
Okay, that's good.
Yeah.
So let's have a chat about some of these machines that are running and what they do, how they work.
So this is one of our most hardworking instrument, which is the multifunction abrasion scrub tester. So when we say scrub test, how many thousands, these are the machine that is scrubbing the panels.
So it simulates like somebody washing a car or something.
Because when early on when I joined the company, the one very frequent question is how long your coating will last, how long your coating will last. So I can do a real life study, wait 5-10 years and then come up with the answer, or I try to find something that we can use as an indicator. So we think, okay, how many car wash can you last? So car wash requires sponge and everything, so that's why we choose this machine to measure the durability. It's not perfect, but at least we can get an idea. Like generally we combine with other details as well, and of course we still do run our real life study to see how long it actually lasts.
Is that a weight on the top?
Yes.
Okay, so the pressure is controlled and obviously the speed is consistent. where if you give me something to, okay, put this on the car and scrub it and tell me if it's washed off, and then you give the same thing to my wife, who's half my size,
different.
she's not going to press as hard.
So even the machine, right, when we buy, I mean every machine that we purchase to be used over here, they have its related ASTM method to it, correct? So we just don't buy something like, oh, okay, it's some, doesn't match.
On the other hand, we can also use it to study our cleaning solution to see how fast it cleans. But the arrangement is normally different lah. The reagent would be the one in the sponge, and then the panels would be the standard soiler, for example, grease, whatever that you want to try and clean. So that you can see how many RPM. So very consistent. You can differentiate between your prototype.
I thought, you know, we put some soap in the bucket, so how does it feel?
So what we do is that in the initial stage, right, this is for the more like in a controlled environment, getting the result that we kind of like we wanted to see, or the machine will tell us what the real result is. Then from there, we will then go to
real life testing.
Yeah, real life testing, and we try to link it together. So this is what is very important. Not everything that we do here is just machine and that's it, go to the market. But we always try to link back to the market. I mean, in real life.
Yeah, because for example, when I'm developing a product, it's not like I make one solution or let's try it. No, I have to make 10 different ones. So if every single one I need to test real life, that's going to waste water, time, and energy. So I can do at least screening, and I say, okay, these are the high potential one, and then we proceed with those high potential prototypes.
What kind of products can you test on this? So in the IGL range?
Oh, wow.
Anything, up to your creativity.
Yeah.
But of course, coating typically is for durability, but cleaning, polishing is for something else. As long as you can think how to create the experiment, then you can use it.
That's very impressive.
But within the confine of the ASTM method. So like Dr. Rafiq is not going to be in this lab all the time 100%, because once he, like you mentioned now, once he verified the prototype and everything, then he will be in the experience bay, because that's when he will like, okay, how does it feel when we are using this product in an actual environment? So there will be a link back to it.
And there's another machine, so they're the same, but that one's just two.
Hardworking, not one is not enough.
Yeah. Before we had two, right? There's a long queue for this machine, so we have to buy a second unit. The next one that we use quite often is this unit.
UV chamber. Okay.
Both studies durability. However, this one involves exposure to UV.
How much it can withstand UV before it starts breaking down?
Yeah, basically that.
1 day in this machine.
Okay.
How does that equate?
This is a favorite question among many to UV. So we cannot simply answer that, because we need to do a correlation study, which we are doing right now, because we need to compare the decomposition inside the chamber and in real life. So for example, in front of the office, you see we have that multiple panels, all are coated. So we are actually comparing how deterioration in real life and deterioration in chamber. After that, if we can get a correlation, then I can answer your question. And if 1 hour equals to how many days?
It's a very ongoing study.
But it cannot be.
It's ongoing for the last 3 years. And in real life, there is a combination effect between the weather, the pollutants in your place, and UV. Those might synergize, that might kill your paint even faster. So this is a very complex things to study.
It seems to be.
But at least with this chamber, we are able to see in lab scale. Like for example, we do 1,000 hours standard. Then we see, okay, which coating can at least survive 1,000 hours of this chamber. And in real life, it might be even more than that.
And 1,000 hours is 1,000 hours. So you will put something in there and run it for 1,000 hours continuously.
Correct.
With constant level of radiation.
So for us, like, there's a lot of things that we have. Some of the products, right? We already know its performance in a way. So for us, these machines act more like a comparison study. You can actually do a lot of comparisons, like, is this better? Is it weaker? And then the 1,000 hours, what does it mean in terms of product development? Like, how does it actually like help us? So
for example, when you develop a product, you want to make something at least better than the predecessor.
Correct.
So when I do UV, I cannot have weaker UV than my
Yes.
predecessor. That's the simplest way to put it.
But it still takes a long time. Like if you're going to run something
is.
for 5,000 UV hours, your machine is tied up for 5,000 hours. You cannot use it for anything else.
Depends on space. Depends on the space.
Thankfully, this one setting normally, regardless of sample, they use the same setting. So you can always, as long as you can track the individual panel timing and everything.
So here we have a few machines. They are just ongoing working non-stop 24 hours. No choice. We just have to get the study done.
Developing industrial products is easier because they have clear specification. So as long as we meet those specs, fine. But automotive is the way others like must look nice,
Yes.
perform super.
Actually, automotive coatings are the most complicated and difficult because its aesthetic requirement is very high, and your eye, it's really within your eye level to see.
So on that, and thank you for mentioning that because it actually puts it into perspective. So you said that industrial coatings are easy to lube because they have specific STM. So if I'm
Easy.
well, not easy, but I mean clear. Because what happens, like if I'm a manufacturer or if I'm ExxonMobil or whatever, I'm a company, I'm a big company, Westtrack, whatever it is, and I'm looking for the next generation of paint for my machines. I will go out to the market and say, I need a product and these are my ASTM expectations. Or you must have the results for these ASTMs. So I can compare 20, 30, 40 manufacturers. But in the automotive industry, there is no regulation. There's no requirement to provide any STM.
Depends on the industry. So if you talk about the industrial side, they normally will have a tender with the specs and requirements based on their existing experience. So that's where they will source for the supplier and so on.
And
unless they are working on a pilot new project where they are very open to new innovations. That would be a whole different discussion altogether.
And if it's for a tender and they say, okay, we need these ASTMs,
correct,
you must have these ASTMs.
You must have it. They will have a full spec. If you don't meet, don't waste your time because they are not going to look at it.
So I can't send them a YouTube video.
No. No, okay. They will have a full list. So we have done a few submissions, and if anything that's missed out, there's no point. Because this is what they're using existing, and if they're looking for something better, they will up the requirement. Like, okay, we need to meet this requirement now. So they have to do it. For automotive, right, we talk about the automotive industry in terms of the tier 1 suppliers to supply to actual car manufacturers. It's the same thing. They have the same full process in place.
But that's for like paint. Like if you're
correct
a paint company, but if you're a detailer,
yes, that's the issue. So how would you say it? The car care industries are not that regulated.
So there are ASTMs in place, but there is no requirement to share or demonstrate.
Sure, there's even
or validate.
Actually, what happens in this kind of industries is that experts will meet yearly and they would iron out. For example, when you say your coating is hydrophobic, must be angle at least how many. So that is the start. From there, you iron out all these.
And that's for
details.
the big industrial companies.
Yeah, there is no for all mature industries. However, for detailers, we haven't, I think, achieved that level yet. But it might in the future maybe.
Maybe.
We're getting there. We have bonnets that we're coating and putting outside and housing.
Because one of the trends is that what I saw is even the car manufacturers are now interested in the detailing liquids. So they are used to having specification. So I don't think they are comfortable living without.
So it's heading towards a specific direction.
Actually, already started. So like what Dr. Rafiq mentioned, the car manufacturers, yes, they are, and they has thrown us with a few standards that we have to comply with. So and that's where the control is coming in. But when it goes to any, I would say, not corporate, but smaller business owners, it is not there yet. But I believe that the bigger guys, right, as they enforce this eventually, the rest will slowly pick up from there.
A whole cupboard full of equipment.
Yeah.
These are all the small
So
stuff.
so we have the larger instrumentations. We have like some of the small apparatus. We have we do our oven testing as well for heat.
Okay.
It's more like for
What's the oven testing for?
lot of
Product
purpose.
stability.
Yeah.
Product-
Packaging.
Or heat
Packaging and
resistance as
product
well.
stability, yeah.
So that is stability, so more like storage or transportation.
Okay, so
Yeah.
normally once we have done with our internal evaluation and we start giving our customers to test, that is also when we start to do the product stability. Because there is no use if the prototype only lasts 1 month. It needs to be at least 1 year on the customer's shelf, right? So that's why we need to do stability to ensure that the liquid, the product itself is still good and the packaging itself is not damaged.
We can't just like, develop a product and then we just put there and wait 2 years, 3 years. Okay, time for launch.
No.
No, we can't. So we do a lot of comparison. Again, comparison study and accelerated testing.
We call it climate chamber.
The climate
control
chamber.
You can control the temperature and humidity.
Wow.
Yeah.
So if this all links back to the quality discussions we have already had, for the people watching this on YouTube, as part of the online academy for IGL, we have other tutorials that talk about the QC and the science behind things. So it all ties in. So you make a product, you make sure that bottle is strong enough, you make sure that the product performs as it should using various testing methods. Then, so the packaging is selected, the product is developed, then you test it in real life, and then you also make sure it lasts using the climate chamber.
Yeah.
Okay, let's go and see now what other things we can talk about. So we're now leaving the dry lab.
Yeah. And I think we missed the explanation about
Yeah.
the differentiation between wet lab and dry lab.
Yeah.
So basically, when we say dry lab, doesn't mean that there is no water or whatever inside. It's just that we don't do formulation work inside the dry lab to keep the lab relatively safer.
Okay.
And this wet lab is where we do most of the mixing and formulating work. So chemicals can be flying around here. So wet.
As soon as you said safer, I imagined somebody mixing something and it's going boom.
It could happen. We had
Yeah.
explosions before,
Whoa.
We did.
Wow.
but no fire.
No
Just-
fire.
Just explosion. Okay,
Wow.
so this is immersion chamber. So for example, when we need to do some tests at constant temperature and constantly immerse in the liquid, this is what we use.
So IGLA just recently was 4,000
Yeah.
submersion hours.
Correct.
It would be with a machine like this.
Yeah, so we would immerse the panel here using the Lego holder, and inside this beaker is the testing solution. Outside here is the heating liquid.
And the liquid is maintained at a specific temperature.
Yes, depending on customer requirement. For example,
Okay.
some customer require 40 degrees C, so we set at 40 degrees C.
Total Rafik said just now, right? It's the customer
Customer
requirement. So most of the time we have our STM method they have, and then they will have their own requirements.
Because the STM doesn't always like spell A, B,
Correct.
C. They can also, or any temperature your customer likes.
Right.
Because in your customer's place, he might need to
Makes
make it
sense.
to survive at 80 degrees C. So you cannot stop him from testing at 80 degrees C. Right? This is all our mixing
Mixers?
equipment.
Yeah, I think we can talk about like the abrasion tester.
Okay, abrasion tester.
So for armor, one of the key properties is to resist abrasion.
Yeah.
So this is how we do it. We have standard table brand
Abrasive?
abrasive. Yeah. So this one is selected CS17.
Okay.
Normally we use two different. Another one is CS10. CS10 is less abrasive. CS17 is more abrasive.
Okay.
So you would mount your sample here, for example,
Yeah.
and then you put the wheel here, and then we rotate.
Okay, so it rotates and it keeps going.
And after every 100 cycles, you will need to weigh and see if there is any difference or not. That's how you know your coating has been abraded away or not.
Normally when you think of abrasion, you describe it as, oh, is it still there? But if you're weighing it, you have a
Yes,
number, no longer like an opinion.
No
Because
confidence.
it's hard to tell your customer how good is your abrasion. Oh, I rub it for 1 hour. It's like,
No.
oh.
Yeah.
What's the sensitivity of the scale or the accuracy of the scale? Like when you're weighing it, like, you're not removing kilos of material. It would be
Ours is 4 digit in our lab, 4 decimal point. So this is how we study how long it takes for a paint to cure. So for example, let's say
Aegis. Let's use Aegis as an example because
Aegis.
that is the number one discussion point always is the curing time
The
and
drying
tacky and not tacky. And so there's a machine that actually tests that.
So this is the dry time recorder. We have 3 different lanes. The difference is that you can change different timing for each lane,
Okay.
according to your study. So for example, what you need to do is you have this glass strip, and then you will use an applicator to apply a thin layer of your paint according to your thickness, 75, 150. So normally,
So 75 microns and 150 microns.
unfortunately, there is no 50 micron.
Oh, so-
if you want to buy, it's damn expensive. So we just use whatever we have.
150.
Yeah, so 75.
Okay.
The thinner one. And then we apply it like this. So you have a layer of paint. And then you would mount it here. And then you put the pin there and then just run. So the rate of movement is depending on your timing here. For example, this one I set 12 hours. So after 12 hours, it will move from
Oh,
end to end.
okay. I get it. So it will just keep moving, and as it cures, you could actually see if
As you
how it
can see
looks.
here, this is the pattern from beginning, and then 12 hours is around here lah. So when you have a different curing rate, you see the pattern is longer.
Yeah.
This is Aegis original. This is Aegis with the faster cure.
Wow.
So you can see this. There is definition for each of these phase, but I'm not confident to explain now. But you can see here it happened at maybe 12 hours is. This one is around 4 hours. This 3 hours.
So that makes a lot of sense when somebody says, "Oh, my Aegis is not curing," or this and that.
Yeah.
This is very controlled.
Yeah, because curing is a factor of temperature and also humidity, at least for Aegis. You need certain temperature for it to start to cure. And after a certain temperature, even if you heat it past that, it
won't go cure faster.
accelerate the reaction.
I always thought, okay, you guys sprayed something on, you applied Aegis, and you're more like either feeling it or testing it manually. I didn't realize that it's actually a specific machine.
Correct. So a lot of all our coatings, right, we have the technical data sheets.
Yeah.
Where it spell out the dry time, the application method and everything. So all this, the documentation, right, is actually written based on the testing that we do over here. So that's how we give you a standard technical data sheet method.
That's interesting. Well,
That's why I'm very confident of the curing time.
yeah, and I have seen the technical documents many times, but I never really understood the method until now. It's a good way of validating changes. So the accelerant, you can clearly see the difference.
Every batch that we produce also, they will check the curing time to make sure that everything the same. Because this is the number one question that people will complain.
Yeah.
It doesn't cure.
Yeah.
Okay, confirm. We did the test already, it cured.
So this is why the traceability is very important. The moment someone complains, we ask the serial number of Aegis.
Yeah.
Then we will cross-check back all the way to like, okay, what's
the
the testing
result.
result of this? Okay, it actually is fine. So then we will then question back. So how was the application method? How was it done? Like, what's the temperature? And everything. We do a comparison from there.
That's why we have asked a lot of questions because
Yes.
we
You need to
already
replicate.
have certain ideas. We just need to navigate to which possibility it is.
So in the next few months, we'll have a couple more instruments that we just procured. It's going to be here. They will actually extend our testing further.
That's awesome.
Because for example, I think a lot of people have been asking for matte edges, for this modification, that modification. So any modification is possible. But on our side, we need to ensure that the performance is on par, or at least we are comfortable with the performance.
Yeah. So as Dr. Rafiq mentioned just now, so like if we had to make different iterations of different products, right, and then the only way for us to do result comparison is we have one equipment right now, it's a salt spray. And if we had to do 6,000 hours for every single iteration, it's going to take forever.
Yeah, well, 6,000 hours. How many continuous?
How many?
6 months.
6 months. So 6,000 hours is continuously 6 months.
Correct.
So every time you try to do a new test.
That was how we did it last time.
Correct. That's how we did it.
Do prototype and then work on a different project.
Yeah. So now, right, I mean, Aegis has accelerated a lot in terms of its usage, so we can't afford to
Wait 6 months,
to
no.
wait anymore. Because before this, we were kind of like development stage, not many people, like not even launched properly yet. So we had the time. No one
Yeah.
knows. So now people know, and there's a lot of requests about like the thin version, the UV version, the matte version, aerosol version. So we need to make a lot of iteration, even colors and stuff like that.
And you validate every single
Correct.
change.
So this is why this year, right, we're investing in more instrumentation that will help us to speed up the development in a lot faster manner.
That's good to know. It's
Yeah.
reassuring for me. And I get asked from my applicators, okay,
Correct.
what paint should I put in with Aegis? What should I do with? And
Yes.
my response is always, it's always the best to stick with whatever IGL recommends
Correct.
or supply, because it has been tested and validated. Remember the question about the hardener? Somebody said, oh, just put a little bit more hardener. They said like that.
Oh, yeah. No, they have to follow
the spec.
KDS.
Must
We
follow the
have
spec.
Done it optimally. So,
Because tested.
yeah. So this is why we are investing a lot into this. So because this is something that we foresee will help the installers to actually to open up new markets and new industries.
There is one thing that is slightly related, slightly not related, that I want to ask you about. I noticed a few university students. I know you have some interns. I know you have some university students. I think you used an abbreviation about your
It's a CSR. So,
that one, yeah.
So for us, this is kind of like also our way of giving back to the industry in a way, to the country. So it's more like a corporate social responsibility where we have students coming in and then we will train them up in an actual working environment with an actual projects to work on. So, yeah.
So this is the instrumentation room.
Yeah.
So what's happening here? Is that microscope or something?
No, it's a contact angle measurement instrument. So we actually measure the contact angle of the correct coated surface.
So there's a few drops of water there.
Yes.
Water beading. So what's contact angle?
Okay, so the behavior that all details like to see the hydrophobic.
Oh.
So what we are doing is we are measuring the hydrophobicity.
Okay,
Correct.
there's a specific way to measure it.
Correct.
So we don't go outside and just spray it and say, oh,
And
look
then
how
you're
hydrophobic it is.
Correct. So even down to a point where I say hydrophobic, like there is a number associated to it that gives you the behavior.
So when you say that Kenzo is more hydrophobic than Elixir or vice versa, or whatever it is, or Windows more hydrophobic, you guys actually have a scientific way of proving that.
Yes.
It's actually measured. It's
Correct.
not a
Correct.
assumption.
Using an instrument, following an STM method to get the numbers that we want.
Okay, and that's a pipette or something. So even the size of the droplet is
It's controlled.
controlled.
Yes, everything is controlled. So there's no unnecessary variable, and everything is following the STM.
Is this only done as part of the product development, or is this something you guys do?
Oh, it's from product development to product validation to comparison study if you need to do, and even during QC stages as well.
Okay,
Yeah.
so there's always some sort of checking.
Correct.
That's pretty cool. Right, so now we learned about the hydrophobic testing. This machine here, and very small machine, but you mentioned to me is very important machine, and it ties in with what we spoke about in the QC video, the tutorial about how materials and ingredients are tested and chemicals are validated. So Dr. Rafiq, can you let us know a little bit more about how you check and what this machine does?
Okay. Yeah. So as you know, materials are comprised of different atoms, oxygen, carbon, hydrogen, and each of these components have different bonds, like double bonds, triple bonds, a lot of different arrangement. So when the ray hits those materials, all these different arrangement of atoms can be detected and is illustrated in the pattern. But you don't actually see the pattern here. You need to understand how to read the pattern to see what is actually happening.
I've seen this in CSI. I've seen it in CSI where I'm sure it's fake, but they load up a chemical and say, okay, so this chemical after looking at a machine is this product. So something like that, but real, not fake.
Yeah. That one is actually real technology, but they fake the time part. Because normally it takes days, but they done it. It's like 1 hour I have already. It's a fiber.
That's very complicated. That is some really technical stuff.
Correct. So this is how our QC side, right? I mean, from the product development stage, they have identified the materials to be used, right? And then they have kind of saved it in the instrument.
On product development stage, we don't use it simply to identify because we know already the chemical is correct because we got the sample from our supplier. But when we do reaction, when we do coating, we need to do reaction, right? So we use this to determine whether the reaction has occurred or not. Because we can detect, okay, for example, this bond should disappear because it already bonded, become something else. So the peak should either shorten or like shift up. So
That's
for
amazing.
development side, that's how we use it.
You can actually tell at an atom level what's happening. If you're getting the desired outcome, like if you're trying to target a specific function or specific chemical compound, you can validate with this machine. You're not guessing, you're not saying, okay, this is formula number 750, let's apply it onto a door and let's see if it does this better than the previous formula. You're actually validating at a chemistry level.
Correct.
And with QC, like let's say for example, somebody says, okay, there's a problem with my Kenzo. And you think, okay, I wonder if it's this specific function. You can actually check it and say, okay, at a chemical level, this product is the same. There's nothing changed. It is not a chemical problem.
Correct.
That's amazing. That is really...
It's also part of our incoming inspection as well, because once we have finalized the material to be used, it's saved in the database, and that determines all the peaks and the way its own fingerprint, correct? Then when
consistency.
when we have the incoming materials coming, we always will cross-check, does it match?
And out of my curiosity, how long does it take to actually, like let's say you're inspecting some raw ingredient. How long does it take to do this? Is like you guys running tests all the time?
Per spectrum, less than 1 minute.
Wow.
It's short. Analyzing is a bit longer.
Well then, the graph means nothing, is it? The graph, this is for the experts to look at. It makes no sense for me.
Oh, you need to actually go for a proper course to study for all this.
To understand FAR, you need to study chemistry.
Correct.
That's
So
awesome.
But the instrument itself also is like,
To run, you need to have the refresher course.
yeah.
But even the machine itself is very user friendly that you can, let's say you need your production floor to run it. They can make it very simple so that just touch button, it will confirm run the run that you want.
Cool.
Good. Now we tell them the bad part. So for everybody saying, oh, this machine is simple if you have a chemistry degree and if you have done the course, this machine is like $40,000. So it's very expensive. I'm sure they use it in...
Yeah, and it is quite sensitive to moisture, so that's why we keep it in this separate room.
That's
Climate
amazing.
control room.
Yeah. And that explains your thermometer and stuff there.
So this is the spray booth where we actually run the actual spraying of our products. So products that spray like AJ's, Armour. If you notice in the TDS, right, you know, there will be an area where you have a guideline on the spraying method. This is where we establish like, okay, this is the spray gun that we use, this is the setting that we use, and the amount of pressure is used, and the distance. So all these are studied and done accordingly over here. And then it's portrayed into the TDS.
And it's a proper spray booth.
Yes.
Like you have to have...
Correct. And with proper exhaust, with proper regulation, local regulation with the Department of Environment. Correct.
Pretty much for everybody watching these tutorials, we've really looked at the whole process. The only parts that we're not showing is the truck driver coming into here, bringing raw ingredients, and your truck driver going out, delivering the product. But you pretty much now have seen everything about IGL. And I guess, like I said, those of you on YouTube, enjoy, but please go to the Online Training Academy because there are lots of tutorials that all tie in. And today we spoke about the importance of the testing and validation and the methods. But inside the Online Training Academy is not just how to apply the products, but it's also things that tie in with here, like the ISO quality certification, VOCs, quality control methods, all that. So it's all very important to build a picture of what actually happens behind the scenes of your 20 ml bottle. There's a lot of stuff for, a lot of things in the back end for a few mil of product.
Yeah.
So very, very big operation. So thank you for watching. Please let us know if you have any questions. Please jump onto the online academy. And if you're on YouTube, feel free to comment, like, subscribe, and share. Thank you.